Okay. The first one is the inverse secant, parentheses, negative square root 2.
They want you to evaluate that?
Yeah.
Okay.
And then there's like answers.
Okay. Well, first of all, let's figure out what the inverse secant of square root of 2 is.
Okay.
Okay. If I look at my two special triangles, the one that applies is the 45-45 because that has the dimensions 1, 1, square root of 2. So
yeah, okay.
that tells me that the secant of 45 is the square root of 2.
Yep.
Which means the inverse secant of square root of 2 would equal 45. Well, what's the consequences of the negative? Which quadrant does that put it in?
Oh, it's in quadrant 2 though.
Correct, because this is the reciprocal of cosine, and we're talking positive and negative arguments of cosine or secant. Positive means it's in quadrant 1, negative means it's in quadrant 2. So what's the angle?
Okay. Would it be 3 pi over 4?
Yeah, or 135 degrees.
Okay.
Same thing.
Okay.
Okay.
Okay, yeah, I get that one. That was just dumb. Okay, next one.
It's almost always, especially the ones where you're supposed to do them without a calculator, it's always going to be one of these two triangles for solving for the angle. And then it's just a question of placing it in the right quadrant. The first thing I always do here is figure out what is the reference angle going to be. And I can get that from these two triangles. And when you told me square root of 2, the only dimension in either of these triangles that's square root of 2 is this 45-45.
Yeah.
All right. What else you got?
Okay. Okay. This one's pretty long, but it's cosecant, parentheses, and then it's the inverse of sine, parentheses, negative 3/5, plus the inverse secant. Huh?
Do I need an end parentheses, or is it like that?
No, it's still just like that.
Okay.
And then the inverse secant of negative 4. Oh, yeah. Okay, sorry. The first one was cosine at the very beginning. I said that wrong. My bad.
All right. Cosine like that?
Yeah.
Instead of cosecant?
All
right. So
there we go, yeah.
We have to do these without a calculator.
Yes.
So we need to find the triangles that fit. Well, this triangle here, remember that's always the way you want to start these.
Yeah.
Okay. This triangle is, if that's theta, remember how I wanted you to do these. Let me call this, alpha. I'm going to call that angle alpha and this angle beta. And that's the best way to do these problems, I'm convinced.
Okay.
Okay, so if I make that alpha, dimension this triangle for me.
So it'd be negative 3 over 5.
No, forget the negative sign for the moment. That will allow us to place it in the quadrant we want. But
Okay, so just be in 3
it's a
and
3,
5.
4, 5 triangle, right?
Uh-huh.
In other words, the sine of alpha would be 3 over 5.
Yeah.
Okay. Now, let's draw a triangle for the secant one. It's not a triangle that we're particularly familiar with, but I know the secant is hypotenuse over adjacent, so that's got to be
Yeah.
4, that's got to be 1, right?
Mhm.
And this is beta.
Okay.
Well, this side over here has to be what? Square root of 8, which is 2 root 2. You with me?
Wait, how'd you get the 2 root 2?
Well, it becomes, oh, sorry, I made a mistake. That's how. It's square root of 16 minus 1, so it's the square root of 15.
Okay.
Yeah. All right. Now, we know that alpha is fourth quadrant angle.
We do. How?
Yeah,
Sorry.
because the inverse sine, if it's positive, it's in the first quadrant. If it's negative, it's in the fourth quadrant and is a negative angle.
Okay, yeah.
So
Mhm.
it's whatever that angle is there, which is like 37 degrees, but it's the fourth quadrant. It's minus 37 degrees. Okay.
Okay. So what number do you put the negative sign on? The 3?
No, I put it in front of the 3/5.
No, but like in the triangle.
Right. There's no negative sign in the triangle. We don't use negative signs in triangles because all dimensions are positive. Okay. Is
Oh,
all I know is that it's that angle, but in the fourth quadrant.
okay.
Okay.
Mhm.
Now, let me think about this for a minute. Um, so let's see. If I could use a calculator, I would know that angle was 37 degrees minus 37 degrees approximately. Let's see if that helps us. Now, on this lower one, that's beta.
Yeah.
Which quadrant is that in?
Secant. Would it be in the second quadrant?
Yes. In other
Okay.
words, it goes with cosine. It's the reciprocal of
Yeah.
cosine. And when the inverse cosine is a negative number, you're talking second quadrant angle.
Okay.
Now,
Well, what
ah,
I did originally
you
was just the,
use the sum and difference formula, right?
yeah.
So what do we have? We have the cosine of alpha plus beta. Let me work down
Yeah.
here in the lower right. That is going to be the, what is it? What's the identity for it?
Um, cosine alpha, cosine beta, um, well, is it minus?
Minus. It's
Minus
opposite
sine
of
alpha
this
beta.
sign here.
Okay.
And I know that there's always two cosines and two sines in this, whether you're doing the cosine sum and difference or the sine sum and difference.
Mhm.
The answer has two cosines and two sines in it.
Yeah.
All right, well, let's see. Let's see if we can fill in all these. Do we know the cosine of alpha?
Yes, it's
Mm,
4/5.
4/5 plus or minus?
Uh, Is it
Which quadrant is alpha in?
fourth?
Cosine of fourth quadrant is plus or minus?
Plus.
That's 4/5. Now let's look over at this triangle. We know that beta is second quadrant. What is the cosine of beta?
Negative 1/4.
Minus, what's the sine of alpha?
3/5 negative.
Negative 3/5. Be very careful here that we don't drop a negative sign. It's very easy to do when you have two of them together. And what's the sine of beta?
Square root of 15 over 4.
Positive or negative?
Positive.
Because it's which quadrant?
The second, and sine is positive there.
There's our answer, which can be simplified. Let's see if what we get when we simplify it. We get minus 4/20. These two minuses are going to turn into a plus 3 root 15 over 20. So you should find some answer in your multiple choice that looks a lot like that. Do you?
Yep, I see it.
Okay.
I don't know how I screwed that up.
Well,
I didn't.
This is a tough problem, although if you attempted to do it using the sum and difference formula, it actually turns into a pretty easy problem as long as you draw the two triangles. Because
yeah, I just made an algebra mistake.
It's only after drawing the two triangles that you can dimension all three sides. And that's needed to figure out the cosine of alpha, the cosine of beta, the sine of alpha, and the sine of beta. And you have to figure out which quadrant they're in. So you're using the principle. In other words, if I have the inverse sine of a negative number, that's fourth quadrant. If I have the inverse sine of a positive number, that's first quadrant. If I have the inverse cosine of a negative number, that's second quadrant. And if I have the inverse cosine of a positive number, that's first quadrant also.
Okay.
So you kind of need everything you see on this page.
Yeah.
You need to draw these two triangles and dimension all three sides, because what it gives you here only allows you to dimension two of the sides. So you have to figure out the third side. And then using the sum and difference, you can put it into these four terms here, and we can figure out all four of these things from these two triangles. I personally think the key step is this one right here. Just the labeling. Calling those two different angles. In other words, what this expression means is it's the cosine of this angle plus this angle. Always remember that when you're taking inverse trig functions, you're getting angles.
Yeah. And
once you call it two different angles, well, now you can draw a triangle and label those angles and label all three sides, and then you can answer these four things down there once you figure out which quadrants they're in. So there's a lot to this problem. It's not an easy problem, but doable by the methods that we just did, that we just used.
Oh, yeah, I totally see how I screwed up.
All right, what else you got?
Okay, I'll just read you the problem because it's partly words. So it's if the cosecant of theta equals 25 over 24 and tangent of theta is less than 0, then we have to determine the cosine of theta divided by 2.
Okay. This is like the classic trig problem. Okay. This, and I mean that, really. It's where they give you one trig function's value, and they give you enough information to figure out which quadrant it's in. Which quadrant is the cosecant positive and the tangent's negative?
3.
Tangent's positive in third. All students take calculus.
So is it the second?
Yeah, because in the second, the reciprocal of cosecant is sine. Sine is positive in the second. Tangent's negative. So this tells us that it's second quadrant. Okay? And furthermore, we can draw a triangle. This is usually part of the problem, is drawing this triangle and dimensioning it. Well, what can I dimension? Even though we're in the second quadrant, we're going to set that aside for a minute.
Okay.
Okay? What are the dimensions of this triangle right here? What's the hypotenuse?
25.
Which side is 24?
The short side.
The opposite theta side.
Yeah, opposite theta.
Because the way I've drawn it, I don't know which is the short side. But it's got to be that, because the cosecant of theta is 25 over 24. It's the reciprocal of the sine, which is opposite over hypotenuse, so this must be hypotenuse over opposite. Now, we need to label this bottom side here. Well,
7.
Okay, good. That's a Pythagorean triangle, a perfect one. Okay, so now we have some identities for half angles. What are they?
Oh, for cosine?
For cosine. And this is not the one where you have 3 different ones. In other words, the cosine of 2 theta has 3 different identities, and you really need all 3 of them periodically. But the cosine of theta over 2 is what? Remember it?
It's plus or minus the square root of 1 plus cosine of theta over 2.
Okay. Well, we know what the cosine of theta is, so let's just answer that, and we'll know whether it's plus or minus based on which quadrant it's in.
Okay.
First of all, let's plug everything in. What is, let me think for a second here. Theta is in the second quadrant, right? Right?
Wait, what do you mean by theta?
From up here, we've got theta has to be second quadrant. Because,
theta.
Because the cosecant is positive and the tangent's negative. So we know it's second quadrant. Well, if theta is second quadrant, which quadrant is theta divided by 2 in?
The first quadrant?
Yeah. So we know it's the plus answer, not the minus.
Okay.
Okay. So our answer is going to be plus all of this, 1 plus cosine of theta over 2. Now, what's the cosine of theta equal to?
7/25.
Plus or minus?
Minus.
Correct. So we've got this, plus the outside, 1 minus 7/25, because cosine theta is in the second quadrant, so cosine of theta has got to be negative, all over 2. And that's your answer. Now, that can be simplified. Let's simplify it a little.
Yeah.
How do you simplify this?
You multiply the top by 25.
Well, let's do this. Let's let 1 be 25 over 25 minus 7 over 25. That's equal to the square root of 18 over 25 divided by 2. Well, now that's the square root of 18 divided by 50.
Whoa, wait. 18. Oh, okay, yeah, I see.
So I got to divide that by 2.
Mm-hmm.
And now, let's see, can I simplify that any? That's the square root of 18 divided by the square root of 50. Well, the square root of 18 simplifies to what?
2 root 3.
3 root 2.
3 root 2.
In other words, it's root 9 times root 2, and root 9 becomes 3. Square root of 50 simplifies to what?
To 5 root 2.
Ah, the root 2's cancel. Bingo. 3/5.
Oh. 3/5.
3/5 is the answer.
Yep, I see that one.
Okay. That also is a little bit of a difficult one, and we didn't cover any like this in our previous sessions. And by that I meant, well, once we determine that theta is in the second quadrant, we have to know which quadrant theta over 2 is. And that's a leap that we've never talked about before. There's no, if theta is in the second quadrant and you divide it in half, it has to be a first quadrant angle. And
what if it's in the third quadrant?
Well, then that's a good question. Well, no, half of the third quadrant has to be second quadrant.
It does?
Yeah, third quadrant goes from 180 to 270. So if you take half of each of those, we're going from 90 to 135. That's second quadrant.
Yeah.
So you can always figure out if you know which quadrant theta is in, then you can figure out which quadrant theta over 2 is in. And that allows you to choose either the plus or the minus.
Okay.
Okay. Now you still have to figure out cosine of theta, which turned out to be negative because theta is in the second quadrant. So cosine of theta is going to be negative. And that's why we subtracted 7/25.
Yeah.
And then you just have to do some sophisticated algebra. In other words, mainly, the main process here is subtracting those two numbers.
Yeah.
And the best way to do that is just find a common denominator of 25, do what I did, and reduces to 1825 over 2, and then that nicely gets rid of the radical sign altogether, and we have a positive answer because we know theta over 2 is first quadrant.
Okay. Yeah.
Okay, what else?
I just have one more quick one.
Good, because we only have 6 minutes. I have a 7:30, unfortunately. So.
Okay, it's cosine squared of 40 degrees minus the sine squared of 40 degrees. I was super confused on this one. And it said, like, which expression is this equivalent to?
What are the 3 identities for cosine of 2 theta?
Well, one's just cosine squared minus sine squared.
Ah. That's what we're looking at, right? In other words, that's a true statement. So, theta is 40, right? Which means we're looking at the cosine of 80, 2 times theta.
Oh gosh, okay, I did it divided by 2, that's
I gather that this was a calculator question here?
No, none of it's calculator.
None of it's calculator.
Nope.
Well, that presents a little bit of a problem because we don't know what the cosine of 80 degrees is.
Oh, no, that was it. That was as simplified as they had it.
Oh, okay. That was one of your answers on the multiple choice?
Uh-huh.
Okay.
Yeah, I just, for some reason, divided it by 2. I don't know why I did that.
And let's just talk about why, we got a minute or two here, why cosine of 2 theta has 3 different identities.
Yeah.
And let's see, one has 2 cosine squared minus 1, and the other one has 1 minus 2 sine squared. Okay. If you need an identity that is nothing but cosine, you use that one. If you need an identity that's nothing but sine, you use that one. And if you need an identity that has both cosine and sine in it, use that one.
Okay.
And sometimes what might cause me to want to use sine? Well, what if I had something like the following? Cosine of 2 theta plus sine of theta minus 2 equals 0. Let's say I'm trying to solve that trig equation. Which identity am I going to use?
The 1 minus 2 sine squared.
Yeah, because then I'm going to have a quadratic in sine. And I'll be able to factor it. I wouldn't want to use the first one because the solution for solving trig equations is to get everything in the same trig function. In other words, get everything in cosine or sine or tangent or whatever, but it's very hard to solve a trig equation if you have one trig function equal to another trig function. If I have sine of x equal cosine of x, well, I happen to know that solution, but it's not that easy to figure out because I have 2 different trig functions. Okay. But by using that third identity here, I'm going to be able to make this say 1 minus 2 sine squared, and now I have a quadratic. It's called a quadratic in sine instead of in x. Okay. In other words, quadratics don't all have to be polynomials. This is a quadratic.
Oh yeah, I remember that.
Why? Because this is the square of that. So anytime your one term is the square of the other variable term, you have a quadratic. In other words, this is also a quadratic. This one factors sine minus 2 times sine minus 1, or plus 1. Set it equal to 0, now you can solve it. That one has no solution. Sine is never equal to 2. And make sure you throw out the ones that don't make any sense. In other words, a lot of times when you have quadratics, one of the solutions doesn't count. It's extraneous. Yeah. And with trig functions, you frequently find an extraneous solution because you end up with sine minus 2 being equal to 0, which means sine would have to equal 2, which is impossible.
That makes sense.
But learn to recognize these odd functions that are actually what I used to call them quadratics in disguise, because you wouldn't immediately recognize that as a quadratic perhaps, or that, but they are. And you know, if you're uncomfortable with factoring it as a quadratic, then let u equal the middle term. And then you'd end up with u squared minus u minus 2, and I can factor that real easily. And then when you're done, substitute the e to the x for the u. And you can do the same thing with trig functions. Use u substitution, and then just factor that equation there, and then resubstitute before you have an answer.
Okay. Perfect.
All right.
Thank you.
You're welcome. Talk to you next time.
Yeah. Bye.
Bye-bye.